everyone, this is a video on the connections between distributions, and I'm going to go ahead and say it's part one of hopefully a series. There's a lot of distributions and a lot of connections between distributions, and we're going to go over the ones that are just listed here on the screen. So the first thing we're going to start off with is our normal distribution, which we'll define with a y distributed with mean mu and variance sigma squared. Now this is directly connected to the standard normal distribution, which is going to be represented by a z, which is equal to the random variable y, which we defined up here, minus its mu over its sigma squared. And this is distributed with a normal distribution with mean 0 and variance 1. Now we'll define a multivariate normal distribution, which is the vector y, which looks like this with y1 dot 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 yn, which is distributed multivariate normal with a vector of mu's. So this would be mu1 all the way to mu n, and a variance covariance matrix where the diagonals are the variances, variance 1, 2, all the way to variance n, and the off diagonals will be represented by C12, C1n, and so forth. The off diagonals represent covariance, so CIK is representative of the covariance of XI and XK. And now we'll go ahead and define our chi-squared. Chi-squared distribution is simply the square of a standard normal, so we're going to represent it by x squared, which is equal to z squared, and is distributed chi-squared with 1 degrees of freedom. Now we can also have a vector, so if we have z squared as a vector, this would be distributed chi-squared with n degrees of freedom, assuming n is the amount of random variables. Now let's move on to the t distribution. A t distribution is the ratio of two independent random variables, one of those random variables being z and then the other one being chi-squared. So t distribution is z divided by the square root of chi-squared divided by its n degrees of freedom. And this is distributed t with n degrees of freedom. Now we're going to move on to the f distribution. And the f distribution is also a ratio of two independent random variables. This time it's a ratio of two chi-squared random variables, each divided by their degrees of freedom. So we have chi-squared random variable 1 divided by its degrees of freedom, divided by chi-squared random variable 2 divided by its degrees of freedom. And this is distributed f n m. It's worth noting that t squared is equal to z squared over 1 and x squared over n, which is the equivalent of an f distribution with 1 and n degrees of freedom. So now that we have all those definitions and laid them out the way we did, we can draw a nice little graph that kind of shows all their connections too. So we have our normal distribution, which is what we started with, which was directly related to the standard normal with the formula we had above. And then we talked about multivariate normal, which is simply several normal variables. In the standard normal distribution, we moved on to chi-squared, which was just the square of it. And then chi-squared distribution, which was, the chi-squared distribution was related to the F distribution up here. So we have chi-squares connected to the F distribution. And then finally we have the T distribution, which again we saw at the very end was connected to the F distribution. And the T distribution was also asymptotically related to the standard normal.